In our previous video, we ruled out some of the possible rational roots of our polynomial. Now we will use synthetic division to try to figure out which of the remaining 4 rational roots is a solution. Let's begin with negative 1/2, our only remaining negative rational root. We'll write negative 1/2 in the box on the left and again write our coefficients. We'll bring the 2 down and multiply the 2 times the negative 1/2. This will give us negative 1, and if we take negative 13 minus 1, we'll get negative 14. Now, take the negative 14 and multiply it times negative 1/2. If you do that, you'll get 7, and then 7 minus 1 will give us positive 6. Then, take that 6 times the negative 1/2, and this will give us negative 3. 9 minus 3, though, gives us 6 again. Then, take our final 6 times the negative 1/2, again giving us negative 3, but now 3 minus 3 is 0. Since this is equal to 0, this tells us x equals negative 1/2 is a root. So our first rational root will be negative 1/2. Now we'll need to check one of our remaining positive rational roots. If you're not sure which one to check, 1 is usually the easiest to do because the math involved isn't too bad. So we will run synthetic division again, this time with 1 on the left, and we will use our solutions from the previous step and continue our synthetic division. We'll begin by bringing the 2 down. 2 times 1, of course, gives 2. Negative 14 minus 2 gives us negative 12. Of course, if we multiply that times 1, that's still negative 12. And 6 minus 12 gives negative 6. Multiply that again by 1, that's still negative 6. And 6 minus 6 gives us 0. This also tells us x equals 1 is a root. So now we have found 2 rational roots. It wouldn't hurt to check our other rational roots as well. We'll start with 1/2. Once again, we'll bring down the 2, and 2 times 1/2 gives 1. Negative 12 plus 1 gives us negative 11, and negative 11 times 1/2 gives negative 5.5. Negative 6 and negative 5.5 gives negative 11.5, and this tells us 1/2 is not a root. We can safely remove 1/2 from consideration. We have one possible root remaining, and let's see if it works. We'll try 3 now, starting again from 2, negative 12, and negative 6, which was our last valid solution. We'll bring down the 2, and 2 times 3 will give us 6. Negative 12 minus 6 will give us negative 6. And then negative 6 times 3 is negative 18. Negative 6 minus 18 would give us negative 24. This is not equal to 0, and so x equals 3 is not a root. We cross that out, and so now we've shown that we have 2 rational roots, 1 and negative 1/2. On this new slide, we'll write down our rational roots, x equals negative 1/2 and x equals 1. Our job now is to write the polynomial with linear and irreducible quadratic factors. Our linear factors will come from our rational solutions, negative 1/2 and 1. We will take the negative 1/2 and move it to the other side of the equal sign, and we'll do the same for 1. If we move the negative 1/2 over, we'll end up with x plus 1/2. That will go in our first parentheses in our factored form. We can also move the 1 over. If we do that, we'll get x minus 1 in our next parentheses. Then, inside of our next parentheses after, will be our irreducible quadratic. To write our irreducible quadratic, we will look to our solutions from our synthetic division. We'll remember the last term in the sequence in our synthetic division. The negative 6 will be our constant term. The term to the left of that will be our first power term, and the term to the left of that will be our second power term. This means we'll end up with 2x squared minus 12x minus 6 inside of our irreducible quadratic. Since all of the terms there are divisible by 2, we can factor out a 2 from that irreducible quadratic. We'll pull that 2 out to the front. We'll keep our x plus 1/2 and x minus 1 the same, and we'll just divide all of the terms in our irreducible quadratic by 2. The 2x squared will change to 1x squared, the negative 12x will change to negative 6x, and the negative 6 will change to negative 3. This will be our factored form. In our next video, we will factor the irreducible quadratic into complex terms.